Okay, so anytime we start out with a physics problem, we want to start out the same way we did with the mole equation. The first thing we want to do is we want to write down our givens. Okay, so in this question it says, how far will a deer, okay, how far means what? Distance. Okay, so we're looking for distance. Okay, running at 15 meters per second. Speed, yeah. Because they didn't give me a direction, that's how I can tell it's not velocity. Travel in 45 seconds. Time. Okay, so I've got V and T. I'm looking for D. All right, obviously this is the formula that I'm going to need to use, but I'm going to need to manipulate it for what? For D, right? Because I'm solving for D here. It's the only thing I don't have. I have the other two parts. So if I want to get D by itself, what do I have to do with T? Okay, I'm going to multiply both sides and move it. Yep, okay. So multiply that side, it's going to cancel. Okay, it's going to come over here. T times V equals D. All right, so you would get a mark for your givens. You would get a mark for choosing the correct formula. You would get a mark for your manipulation / plugging in of numbers. So 45 times 15 equals D. Okay, so you'd get a mark for that, right? And then you'd get a mark for your final answer. Comes out to what? 675? 675 what?
Meters.
Meters. How important are units?
Very.
Very. It's wrong if you don't have them. Okay? Is that pretty straightforward?
Yeah.
That's about as easy as they get, except to get one that has D and T and asks for V. Okay, that's about the only way they get any easier than that one. Right? We're going to deal mostly with ones that are talking about a trip that has more than one part. But we're not there yet. So we'll wait just a few minutes on those. Okay? All right, see if you can solve this one. Give you a few minutes on that one. All right, so on this one here, how long will it take? What am I looking for? Time. Okay. A tortoise to crawl 200 meters. Distance. At a speed of 0.25 meters per second. So obviously that's speed. Okay, so I've got D and V this time. Now I'm looking for T. So V equals D over T. Can I solve for T if it's on the bottom of the equation? No. All right, so what I need to do is move it to the top. Okay, easiest way to do that is to multiply both sides by it so that now it's on the other side on the top, where I will proceed to isolate it by dividing by V. Right, so that means V ends up on the bottom, so we've got time equals distance divided by speed, 200 meters divided by 0.25 meters per second should give me 800 seconds, yeah? Okay, that's a long time.
Very fast tortoise.
Well, no, it's not. I mean, you wouldn't be very fast if you just had flippers on land either.
Tortoises
But they're pretty fast in the water.
Tortoises? Turtles have.
Tortoises die in the water.
Tortoises are
Oh, sorry, other way
straight
around, yeah.
animals.
Tortoises are just always slow.
Yeah. Sorry, I get those mixed up. They both have a shell and they're slow. Okay, right, tortoises have the claws.
Yeah, they have like this.
No, the stubby little.
They actually have feet, whereas tortoises have.
Flippers.
Yeah. All right, they're both slow. This isn't biology. This is the more important science.
Debatable.
No. Okay. Okay, so this is an example of a vector problem, and it's also an example of a two-part problem. Okay, so this is a trip that consists of more than one section. Okay, so I want you to copy that down, and then we're going to walk through it together. Okay, so you see how one of these is done. Okay, so this bus travels first 100 kilometers north in 1.2 hours. So we get the displacement and we get the time. How do I know that's a displacement and not a distance?
Direction.
It gives me a direction, right? okay? And then the second part, it travels 62 kilometers south, so it actually turns around and backtracks on itself, okay? So does that mean that its displacement is going to be less than its total distance? Yeah, because its total distance is going to be 162 kilometers. It went 100 and then it went 62. Distance doesn't care which direction you go, just how far. That's what we were talking about the odometer in your car, measuring distance and not displacement yesterday. Okay? But the displacement here, we go 100 that way, then we turn around and come 62 straight back. We only end up 38 kilometers from where we started, right? 38 kilometers in which direction? North. Okay, so here's what we need to do in a question like this. We need to break it up into the two parts. Part 1 and part 2. And then we're going to have a section for totals. Okay? So in part 1, we know that the displacement is 100 kilometers north. Okay? And we know that the time is 1.2 hours. Okay? In part 2, we know that the displacement is 62 kilometers south. Okay? And the time for that is 0.9 hours. Okay. Here's the thing you need to realize about this formula. And actually, this formula too. While we don't ever actually write this, what these actually mean is this. Average velocity and average speed are the total displacement divided by the total time, or for speed, it's total distance divided by total time. Okay, we don't ever actually write those in the formula, but it's still true that those are what's applicable there.
On like a test, would you ever ask like that entire question and then say at the bottom, instead of saying, what is the average velocity of the bus, you would add to that, what is the average velocity of the bus when it was traveling north to like
No.
Mr. Brain?
No, a question like this, no, I wouldn't make it like that, because then why would I give you all that extra information? Yeah? Okay, so for this one here, if I want to find the average velocity, I need the total displacement and the total time. Okay? If I want to find the total displacement, I need to add those two displacements together, making one of them negative. Is south negative north? Right. Okay? So when we do something called vector addition, okay, we never do vector subtraction. It's always vector addition. And the way you add vectors together is you say that direction is positive and that direction is negative. Okay? That way I can represent those directions mathematically. Okay? Everyone kind of follow me there? Okay? So when I want to find the total displacement, okay, I'm going to go positive 100 kilometers plus negative 62 kilometers, okay, which is going to give me a total of 38 kilometers north. Okay? I have to remember in my head which one I made positive and which one I made negative, just so you know, typically north is positive, east is positive, okay, because that's how an XY scatter plot works. I don't know if you've done this yet in math or not. I'm gonna run out of room. Okay, so positive y is up, positive x is to the right, negative y is down, and negative x is to the left. Well, if this was a compass rose, that would be north, east, south, and west. Okay, so typically north is positive, south is negative. All right, so when I do this, okay, I've now got my, come on. I've got my total displacement, okay? Do I need to, what do I need to do with the times? Add them together. Do I need to make the south time negative? No, I better not, because if I make time negative, what have I done? I've gone back in time. okay? It's saying that it took me negative 0.9 hours to go positive 62 kilometers, or something ridiculous like that, okay? Time is never going to be negative because time is
Always go forwards.
linear, always going forwards. Scalar, okay? It's a scalar quantity, doesn't have direction on it, okay? So for those ones, I just take the 1.2 and I add the 0.9 and I get a total time of 2.1 hours. Okay? Now I can calculate the average velocity over the whole trip. Okay? I would take my 38 kilometers north and divide it by 2.1 hours. Okay, so this car is traveling at 18.1 kilometers per hour north over the whole trip, okay, on average over the whole trip. Does that mean it did that the whole trip? No. It clearly says that for part of the trip it went 100 kilometers north, and okay, it would have been going faster than that. Everyone okay with that idea? Okay, so is that a whole lot more difficult or different than what we just did a minute ago with the simple problems? It's really two simple problems put together. Okay, is really all it is. Okay, you're still using V equals D over T. You just have to recognize what a multi-part trip looks like when you put it together. Okay, now, what if there was a part B on this and it said, what is the average speed over the whole trip? What would you do differently?
You would add the 62 kilometers an hour instead of subtract it. Yeah.
Yeah, because speed is scalar and speed is distance divided by time, distance also being scalar, direction no longer matters. Okay, it's just how far did you go and how long did it take you to do it. Okay, so if I was calculating the average speed, okay, I would have total distance divided by total time, which we said would be 100 plus 62 divided by 1.2 plus 0.9, okay, which would be 162 over 2.1. Okay, so we'd be looking at 77.1 kilometers per hour. Okay, no direction on that because it's scalar. Okay, everybody all right with that? That's where it can get a little bit tricky if you're not really paying close attention to what you're doing. Okay, vector problems work differently than scalar problems do. Okay, I have to keep in mind direction, okay, when I'm doing a vector problem. And with a scalar problem, it's just add, add, add. Scalar always gets bigger. Okay, vectors get bigger or smaller depending on which way they're going. Okay, all right, questions on how that one works? Okay. So here's one just like the one we just did. Okay, see how you do. Okay, let's have a look at this one. So, as with any two-part problem, or any problem for that matter, we want to write down our givens, but we want to split this up into the separate parts. Okay, so in part one, right, the rabbit runs due east at 22 meters per second, so we have this, the velocity this time, 22 meters per second east, okay, for 12 seconds. And then in part two, okay, it turns around and runs due west at 17 meters per second for 32 meters. How did I know that 32 meters was west?
Because
Well, it doesn't outright say that the 32 meters is west, but it says the velocity is west. Is it possible for me to go a different direction than my velocity? No. So I can transfer that over. It doesn't have to explicitly say 32 meters west when it tells me the rabbit was running west at this speed, then, or at this velocity, sorry. Then I know that the displacement also has to be in that direction. Okay? All right. And then I have a column for my totals. Okay, so I need the total displacement, I need the total distance, and I need, whoop, I wrote that twice. I clicked on the eraser, I want the eraser. Okay, so I play that game, are we? Okay. I need total distance, I need total displacement, I need total time. Do I have all that information? No. This is what usually happens with a multi-step question, okay? I don't have the displacement for part 1. Can I find it? I can. I have V and T, so I should be able to find D. So that's the first thing I gotta do. D equals, okay, V times T. So sorry, my manipulation there, V equals D over T, right? I multiply both sides by T, right? So 12 times 22. All right, so 264 meters east. Okay, now for part 2, I don't have the what? I don't have the time. Can I find it? Yeah. Okay, so I'm going to take V equals D over T. I'm going to multiply both sides by T. Then I'm going to divide both sides by V. All right, so T equals D over V. So that'll be 32 meters divided by 17 meters per second. Okay, so that'll be 1.88 seconds. Okay, now do I have enough information to find my total displacement at total time? Is the second part of this question a much smaller part of the whole trip? Is part 2 a much smaller part of the whole trip? It is. Okay, now this is what sometimes happens for people is they're like, oh, I want average velocity. I'll take this number and this number. I'll take 22 and add it to 17 and divide by 2. Because you've been taught all your life that that's how you calculate averages. And it's true. If all the things you're averaging represent equal parts of the whole. So when I want to calculate a class average, which I basically never do, okay, but let's say I did want to do that, I would take all of your scores, add them together, and divide by 27. Okay? That works because each one of you represents an equal part of the whole class. Okay? In this case, if I add these two things together and divide by 2, I'm going to get a much bigger number than I should because this part of the trip is only 1.88 seconds. This part is 12 seconds. Okay? It does a lot more of this than it does this one. Okay, so I have to weight the average. And when we do this, okay, when we do the V average equals total displacement over total time, that does weight the average. Okay, because I'm adding the two parts together, okay, not averaging them. Okay, so it's kind of a misnomer almost when we say average velocity. It's not the average in the way you've been taught to calculate it. Okay. All right, so I want to get the total displacement. I go 264 meters east and then 34 meters west. What do I need to do with those two numbers? Subtract or add them and make one of them negative. The end result is the same. Okay, so 32 meters and 264 is going to give me 232 meters. Which way?
East.
East. Okay, for the distance, what do I do with those two numbers? Just add them, yeah. Okay, direction doesn't matter for that, so that'll be 296 meters, I believe. Okay, and what do I do with the times? Add them. Okay, so 12 plus 1.88. 13.88 seconds. All right, now can I calculate the things the question wanted? I can. Is this question cumbersome?
Yeah.
Yes. Okay, it has lots of little parts. All right, but when we're first learning how to do V equals D over T, it's a good kind of question because it makes you practice V equals D over T a whole bunch of times in one question. Okay, is it something I would put on a unit exam? No. Because it asks you to do basically the same thing 4 times in one question. I don't need to do that. I just need to know whether you can do it. Okay? So, it's just a good way to practice. So on that note then, if I want to find average velocity, I would take my total displacement, divide it by my total time. So 232 meters east, divided by 13.88 seconds. Okay, 16.7. What are my units?
Meters per second east.
Meters per second east. Okay, if I want to find the average speed, okay, then I go total distance divided by total time. All right, so 296 divided by 13.88. Okay, and I get 21.3 meters per second. Do I need a direction on that one? No, that's a scalar quantity. Okay, so I don't need direction on that. Okay. Question, Dan? You had that look like you didn't like what I said. Okay. All right, any questions on that one then? Okay, so things we need to remember. Scalar quantities have magnitude only, so they are strictly a measured value with units, okay? No direction, right? Things that are scalar, distance, mass, okay? So if you measure the mass of something, okay, like a person, 75 kilograms, that doesn't have a direction. That is how much of a person there is, okay? Time, 4 days, also scalar quantity, okay? Vector quantities have magnitude and direction, okay? So that could be things like displacement, velocity, acceleration, force, okay? All of those things have a direction. If I push something, I push it in a certain direction. That's force. Force is a vector quantity.
Would weight be vector because there's force going down?
Weight is a force. Yeah, weight is the force of gravity pulling on your mass. So it does always have direction, and it is
Vector.
down. Yeah, its vector is down. Yeah. Okay. So when someone asks you how much you weigh, this is another thing we do terribly in North American society. Okay. When someone asks how much we weigh, we tell them our mass. Okay. Last time someone asked you how much you weigh, you told them something in pounds or kilograms. That's not how much you weigh. That's how much of you there is. That's your mass. Okay. When we step on a scale, it tells us our mass. It uses our weight to do that, but then it tells us our mass. So what I like to do is mess with people. Because first off, it's rude to ask someone how much they weigh. And so I intend to embarrass them, since they intended to embarrass me by asking. Okay? So what I do is I tell them, when they ask me, how much do you weigh? I say, I weigh 780 newtons. And they look at me, chuckle awkwardly, and find someone else to talk to, which is a win-win for me. I don't like talking to people, and I don't like people who are rude. Okay? And on the bonus side of it, I also didn't lie. Okay? I told them the absolute truth. My weight is 780 newtons. Okay? Because it's how much the force of gravity pulls on my mass. It's what you would feel if I stood on you. Okay? You would feel the force of gravity pulling my mass downwards and exerting a force on you of 780 newtons. It would be highly unpleasant. Okay? But it's what your scale feels. Okay? What does your scale say when you step on it? Mine goes, ow, get off! Pretty sad, actually. Okay. Yeah. So, you can try that next time you're at a party and somebody asks you how much you weigh. Okay? Take your mass in kilograms and multiply it by 9.81. That's your weight. Okay? And it's in newtons. And then they'll go away. And they'll have no idea what that means either. Okay? Most people have no idea. 780 newtons is big. Sounds big, but they have no idea. All right. So covering that stuff. Okay, we've already done easy ones like that and that. Okay, try that one. It's an easy one, but give it a try anyway. Okay, so for this one here, right, we're looking for how long it's flying for. So we're looking for time, okay? They tell us the displacement, 650 meters north. They tell us the velocity, 9.0 meters per second north, okay? So for a bird, that's not really an unreasonable speed, okay? In fact, it might be a little on the slow side, right? Because they can fly, obviously, pretty quickly. If I'm looking for t, then I have to manipulate v equals d over t, okay, by multiplying both sides by t to get it on the top of the equation, dividing both sides by v to isolate it, 650 divided by 9, okay. Okay, gives me 72.2 seconds. Now, what happened to the direction?
Did it change?
Well, it didn't change, but also this was in meters north, and this was in meters per second north. Did I have a north on the top and the bottom? Then it goes away, okay? It cancels. In the same way that the units cancel, right? I have meters on the top divided by meters per second. The meters cancel, and I'm left with seconds, okay? So if you're ever in doubt as to what your units should be, you can always do a unit analysis. All right, so if I'm looking for time and I'm dividing meters by meters per second, okay, think of it as fractions. That would be meters over 1 divided by meters over seconds. If I want to divide fractions, what do I do?
Yeah.
Ooh.
Swip and multiply.
We reciprocate and multiply, right? So we take this second one. Okay, I got a meters on the top, a meters on the bottom. They cancel. I'm left with seconds over 1, which is seconds. All right, so you can always do a unit analysis if you're ever a little bit lost on what your units should be. Okay, I'm going to give you guys about a 5-minute break here before we move on to some different ones. Okay, so it's a 2-part question. So we got a part 1, part 2. Okay, and our totals. Okay, so an elevator travels up 85 meters in 30 seconds. So they give us the displacement, 85 meters up, okay, and they give me the time, 30 seconds. In part 2, they tell me it travels down 60 meters, so also a displacement. And it does that in 20 seconds. So this one's actually a bit easier because we get d and t for both. Okay, they don't give us a velocity for either of them. Okay, so what's its average speed? All right, if I want to get average speed, I need total distance and total time. What's my total distance?
145 meters.
145 meters, because distance doesn't care whether I went up or down. It's 85 plus 60. Okay, so 145 meters. Okay, the total time would be 50 seconds. Okay, so 145 over 50 comes to
2.9.
2.9 meters per second. Okay, do I need a direction on that?
Nope.
Nope, that's a speed, it's a scalar quantity. That's how fast the elevator is moving on average. Okay, for the average velocity, what do I do differently?
Displacement.
Right, I use total displacement, which means instead of adding the 60 and the 85, I subtract them. Yeah, it went 85 up, it came down 60, it's still 25 above the bottom. Would you agree? Okay, so the overall displacement then is 25 meters up. Okay, divide that by the same amount of time. Okay, it still took 50 seconds to do that. It's going to give us 0.5 meters per second up. Okay, everybody all right with that one?
Go.
Okay.
Well, hey.
I agree.
Yeah, we're supposed to be like.
I'm not supposed to have to read and sign.
It's like when we do source
Oh,
analysis.
absolutely you have to read. You should see this kind of stuff you get on the Physics 30 diploma exam. There are some times on the Physics 30 diploma exam where they make you read an entire page of text and answer one multiple choice item.
Wait, multiple choice questions, it's only one word? And all,
and you have to read a page of text.
That's actually crazy.
Reading comprehension is an important part of all of your courses in high school. They only teach it in English. Yeah, well, we do a bit of it here. But.
I might actually do all my science.
Okay, give that one a whirl. What do you suppose tomorrow's quiz question will be like?
Something like that.
Not probably like this one, no, but maybe more like the ones with 2 parts?
Yeah.
Wait, is it just gonna be one part?